Welcome back, everyone. This is Mr. Tanner, and today we're going to be looking at how to balance a chemical reaction. And this drawing here at the top is more or less what your page should look like. I don't think you should have any trouble fitting everything onto one page. My advice would be to make the information from counting atoms and multiplying coefficients, those first two numbers, take up about the first half of your page, and then that leaves the entire second half of the page for these two practice problems we're going to do for step 3. So once you've got, pause it, get this page set up, and then once you've got the page set up, make sure you resume the video. All right, now that you have your page set up, let's look at balancing chemical reactions. And what this really has to do is with the law of conservation of mass, because that law tells us that in any chemical reaction, we need to have the same number of atoms in the reactants and the same type of atoms in the reactants as we do in the products. So everything needs to balance out in order for the law of conservation of mass to be maintained. When you look at a lot of chemical reactions, though, they won't seem balanced at first, so it's our job to balance them. And there's a couple of steps we need to do in order to balance those. So first, we need to learn just how to count the atoms in a molecule that we're looking at. So I've drawn a molecule, or written a molecule down up here. It is calcium perchlorate is what this is called. And we're going to look at counting all of the atoms in this. So there's two parts of any molecule that you need to be aware of. The first is subscripts. And these subscripts are what I've written in red on this molecule. So they're numbers that go below an atom, or sometimes if there's a set of parentheses, they go below the parentheses. So that's a subscript. And then there's also coefficients, and those go in front of the entire molecule. So let's look at what it means when we have subscripts and coefficients. So first of all, if we have a subscript right next to an atom, which is the case for the 4 next to the oxygen, that just tells us how many of that atom there are. So in this case, this subscript here tells us that there's 4 oxygen atoms. If we have a subscript that's next to a set of parentheses, we need to multiply that subscript by all the atoms within the parentheses. So subscripts next to parentheses multiply all the atoms within. So for example, this 2 is next to a set of parentheses, which means this 2 will multiply the 4 oxygens, and it will multiply the 1 chlorine atom. So this multiplies by everything within. And then finally, a coefficient multiplies all the atoms in the entire molecule. So this coefficient of 2 would multiply that 1 calcium and multiply the chlorine and multiply the oxygen. So let's actually go through and count these atoms out. And we're going to be making some changes as we go. So let's start with the very beginning. Before we look at coefficients and subscripts, at the very beginning we have 1 calcium. We know we have, keep the colors the same, we have chlorine atoms, and we know we are going to have oxygen atoms. So we know we're going to have calcium, chlorine, and oxygen. Well, let's look at oxygen first. Oxygen has a subscript of 4, which tells us we're going to have 4 oxygen. But there's also a subscript next to the parentheses that contain oxygen, which means we multiply. So 2 times 4 is 8, which means we have 8 oxygen. When we look at chlorine, if we don't see a subscript at all, it means there's 1. So we have 1 chlorine, 2 times that 1 chlorine, because again, this subscript multiplies. 2 times the 1 chlorine equals 2. And then we have 1 calcium. There's the subscript over here. So this subscript does not apply to this calcium because the calcium is not within those parentheses. So in the molecule calcium perchlorate, there's 1 calcium, 2 chlorine, and 8 oxygen. But this molecule has a coefficient. And like I said, this coefficient means we multiply by everything in that molecule. So because of the coefficient, we actually have 2 times 1 calciums, which equals 2. We actually have 2 times 2 chlorines, which equals 4. And we actually have 2 times 8 oxygens, which equals 16. So I always think it's easiest to save the coefficient for last because then it just becomes multiplication and we've already kept track of all of our atoms. So again, when we count atoms, subscripts next to an atom tell us how many of that atom there are, as is the case with this subscript 4 next to the oxygen. Subscripts next to a set of parentheses multiply by all of the atoms in that parentheses. So that's why we had 8 oxygen and 2 chlorine. And then a coefficient multiplies by every single thing in the molecule, which is how we ended up with 2 calciums, 4 chlorines, and 16 oxygens in these 2 molecules of calcium perchlorate. So now that we've learned how to count atoms, it's just the easiest thing to forget is when you add or change a coefficient that we have to multiply by every single atom. We have to change those atom numbers at the end. So if we change the coefficient, we must remember to multiply all the atoms in the molecule by the new coefficient. So again, for this atom of aluminum oxide, we have aluminum atoms and we have oxygen atoms. And right now we have 2 aluminum atoms. That's being told to us by this subscript. And we have 3 oxygen atoms. That's what this subscript tells us. But if I added a coefficient of 4, if I have to change the coefficient to 4, we have to remember to multiply these. So because of this coefficient, we now have 4 times 2 aluminum atoms. So that changes this to 8 aluminum atoms. We now have 4 times 3 oxygen atoms, which changes it to 12. So it's kind of a review of what we just did, but it's the easiest step to forget. If you change the coefficient, you have to remember to multiply that coefficient by all of the atoms in that molecule. So having gone over that, let's do a couple of practice problems. And I'll show you the steps that I go through when I solve one of these problems. So step 1, I write down all the atoms involved in the equation on both the reactants side. Remember, this is our reactants side. And this is the product side. So I write down all the atoms, all the types of atoms on both the reactant side and the product side. So on both sides, we are going to have carbon. We'll have hydrogen. And we have oxygen on both sides of that reaction. And then I'm just going to count. Before I mess around with any new coefficients, I'm going to count the atoms on each side. On the reactant side, I have 1, 2, 3 carbons from this propane molecule and no carbons in the oxygen. So my total number of carbons is 3. My total number of hydrogens is 8. And my total number of oxygen is 2. So let's look at the reactant side. I have 1 carbon from carbon dioxide, and there's no carbon in oxygen. So on the reactant side, I only have 1 carbon. I have 2 hydrogen, and I have 1, 2, 3 oxygens. So now that I have these atoms written out, it becomes pretty obvious that this equation is not balanced. I've gone from 3 carbons down to 1 carbon. I've gone from 8 hydrogens to 2 hydrogens, and I have 2 oxygens to 3. So now we just choose what we're going to balance first. And I'm going to just start with hydrogen here. So I know I have 8 hydrogen on the reactant side and 2 hydrogen rather on the product side. So I'm going to add a coefficient. And if I choose to add a coefficient of 4 to water, this water molecule of H2O, I now have 4 times 2 hydrogen. So this new number is 8. I now have 8 hydrogen. And I also have 4 times 1 oxygens. So I now have 4 oxygens here, 5, 6 oxygens total. So because of that coefficient multiplying throughout, I now have 6 oxygens. And because of that coefficient, hydrogen is now balanced. I have 8 hydrogen and 8 hydrogen, but carbon and oxygen are still not balanced. So now I'm going to balance carbon. In order to balance carbon, I need a coefficient of 3 here. Because I have 1 carbon, 3 times 1 carbon gives us 3. So because of that new coefficient on the carbon dioxide molecule, I now have 3 carbon over here, but 3 times 2 oxygen is 6. 3 times 2 is 6 oxygen. 4 times 1 is 4. So 6 plus 4 is 10. I now have a total of 10. See how I keep changing this oxygen count as I go? And that's that step 2 from earlier, is you have to remember to multiply that coefficient all the way through. But we're getting close. So if I look at it now, carbon is now balanced. I have 1, 2, 3 carbon over here, 1, 2, 3 carbon on the product side. I have 8 hydrogen on the reactant side and 8 hydrogen on the product side. The only thing that's not balanced is oxygen. Now I know 10 oxygen on the reactant side divided by the 2 oxygen on the product side divided by 2 oxygen on the reactant side is 5, right? 2 times 5 is 10. So that tells me I can just set the coefficient of oxygen to be 5. 5 times 2 gives me 10 oxygen. And I now have a balanced equation. So this balanced equation says that I would react, right, because we have invisible, we have, right, 1 propane molecule plus 5 oxygen molecules will give us 3 carbon dioxide molecules and 4 water molecules. So that's how I balanced that equation. Again, I started by just figuring out what atoms we have, getting a first initial count, and then beginning to change the coefficients in order to balance those. Let's look at one more. So this time I have had aluminum. This is, right, a synthesis reaction. I'm taking aluminum plus oxygen, and I'm making aluminum oxide. So let's count our atoms. We know we have aluminum on both sides of the equation, and we have oxygen on both sides of the equation, and now we need to count. On the reactant side, we just have 1 aluminum, 2 oxygen, right? We get that from the subscript on oxygen. On the product side of the equation, we have 2 aluminum and 3 oxygen. So to me, I always start with the easiest thing to balance, and that's going to be aluminum in this case, because 1, it's very easy to get 1 to 2 by just multiplying by 2. So we'll set our coefficient to be 2 over here. 2 times 1 aluminum gives me 2 aluminum, and now that is balanced. I have 2 aluminum here and 2 aluminum here. So this is where it gets a little bit tricky, because we can't just add, we can only multiply with coefficients. So I have to figure out, well, 2 times what number equals 3? And in this case, it's actually 1.5. 2 times 1.5 equals 3. And that gives us a balanced equation, but there's a problem. Just like you can't have a half human being, there's no such thing as half of a molecule. So when we're balancing equations, we can never, ever have a half molecule. So we can't write a molecule like this, but there becomes a nice shortcut here. Sorry, let's keep that white for a coefficient. I'll make this coefficient white as well. We'll keep them all the same. So this equation is balanced. I have 2 aluminum on the reactant side, 2 aluminum on the product side, 3 oxygen on the reactant side, 3 on the product side, but I have a half molecule, so we can't leave it like this. But there's a trick. If we end up with a half molecule, multiply every coefficient, every single one, by 2. So what this then becomes is 2 times 2 is 4. That gives us a coefficient of 4, and it means we have 4 aluminums. 1.5 times 2 gives us a coefficient of 3, and it means we have 6 oxygens. 1 times 2 gives us a coefficient of 2. 2 times 2 aluminums gives us 4 aluminums. And 2 times the 3 oxygen is 6. So that gives us 6 oxygens. So by multiplying every coefficient in that equation by 2, since we had that half molecule, we no longer have a half molecule and the equation is still balanced. I'm going to just rewrite this now that it's, so to clean it up a little bit. So we ended up with 4 aluminum plus 3 O2 results in 2 aluminum dioxide molecules. So again, balancing equations. Write down your atoms, count the atoms, and then change the coefficients so that when we multiply, we have a balanced equation. You can always ask me for help if something is still not making sense, but hopefully this will help you complete your next assignment. As always, thanks for watching.